Problem number 18. A cylindrical piece of cork of density rho c, height hc and the cross-sectional area AC is in a larger empty cylindrical container of a cross-sectional area AW. Water of density rho W greater than rho c is slowly poured into the empty container. What is the height of the water in the container when the cork starts to float? Problem number 19. A toy elephant is standing on the bottom of a fish tank. The fish tank is filled with water to a depth of 10 centimeters, completely covering the toy. The elephant's legs are perfectly polished, so that there is no water between the bottom of the legs and the tank's floor, and the total area of contact is 0.16 square centimeters. The water has density rho equal 1000 kilograms per cubic meter. The toy has uniform density 2 rho. The atmospheric pressure is 10 power 5 Pascal, and the toy has a total mass 120 gram. What is the total hydrostatic force that the water exerts on the toy? Problem number 20. A bead is threaded on a frictionless wire and launched horizontally from height h with the speed v0 as shown. If the shape of the wire is a step, as in curve 1, then the normal force from the wire on the bead will point inward. If it is shallow, as in curve 2, then the normal force will point outward. There is exactly one possible shape of wire, shown as a dotted line, for which the normal force of the wire on the bead is always equal to 0. What is the horizontal displacement d of the bead when it travels along this wire? Problem number 21. A cork floating in a cup filled with viscous fluid is placed in an elevator. Below is a plot of the velocity v of the elevator as a function of time t. Which of the following plots best describes the height h of the cork in the cup as a function of time? Assume that the fluid is viscous enough to dampen all oscillations, that the fluid does not slosh as the elevator accelerates, and that both the cork and the fluid are incompressible.